Hello everyone! Let me welcome all of you to the world of science. Today we're going to learn a unique kind of waves that I can say we always use but we cannot see. Are you ready? If you are, let's go! Do you ever ask a question just like how things work? Just like how my Wi-Fi router connect my devices to the internet? Or how microwave ovens cook my food? Or how this kind of scanner know my temperature without touching my skin? How the light from the sun reaches the earth? Or how UV light disinfect or kill germs in hospitals and other places? How televisions and radio station send signals? How does my cell phone connect to other phones? And how do X-rays see my bones? This question will be answered by our topic, electromagnetic waves. In today's lesson, we're going to discuss about, first, the development of electromagnetic wave theory. Next, we're going to define electromagnetic waves. And then, describe the transmission and propagation of electromagnetic waves and discuss the properties of electromagnetic waves. First, let's have a recall what are waves. As we all know, waves involve the transport of energy without the transport of matter. It means waves carries energy from point A to another point or point B. Just like this one. A man is moving or holding a rope and moves the rope. The energy from the man's hand will be transferred to the rope until it reaches to the tree. So the energy is carried by the rope and the rope created a wave. Some waves need medium to propagate. Medium is the material where the wave travels. It means propagate means to go through or to move through or transmit in the form of a wave. And these waves are called mechanical waves. Let me give an example. Just like in the picture, a water drop in the surface of water will create water waves. And the energy is carried by water. So the medium of those waves are the water or is the water. Another example is this man. The energy of the man is transferred through the rope and the medium is the rope. Now, I have a question. Can you hear sound if you are in space? The answer is no. Sound is a mechanical wave. Space is vacuum. So there's no medium or material for sound to travel. So we can say, in space, no one can hear you scream. Now, but other waves do not need medium to propagate. It means they can travel even in the vacuum of space. And they are called electromagnetic waves. Now, electromagnetic waves are created by vibration between electric field and magnetic field. Now, to fully understand how electromagnetic waves was discovered or created, let's have a trip or tour in the past. It all started when J.J. Thomson did an experiment and discovered that all atoms have a negatively charged particle called the electrons. Then, a man named Alessandro Volta discovered that these electrons can move or flow and produce current or electricity. He also later created or invented the first electric battery known as the Baltic pile that produced a steady electric current. Next, a man named H.C. Ørsted found out that a current-carrying wire deflected the needle of a magnetic compass. It means that a current-carrying wire produces a magnetic field. And after that, a man named Michael Faraday discovered the principle of electromagnetic induction. It means a changing magnetic field or a magnet through a coil of wire can produce electric current or electricity through the wire. It means there's electricity if you change magnetic field. It is the same principle used in our generators nowadays. And finally, James Clerk Maxwell theorized that oscillating electric and magnetic field can generate each other. It means a changing electric field is equal to a changing magnetic field, and a changing magnetic field is equivalent to a changing electric field. These two fields can be visualized as a single wave propagating through space. That's why we have now the electromagnetic theory. So an electric field can cause a changing magnetic field, and a changing magnetic field can cause a changing electric field, having or producing electromagnetic waves. Electromagnetic waves has both electric and magnetic properties. There are 7 known electromagnetic waves. They are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. These electromagnetic waves are arranged in a certain manner known as the electromagnetic spectrum. Electromagnetic spectrum arrange electromagnetic waves based on their properties. The first property is the frequency. Frequency is the number of complete waves passed to a point in a given unit of time. As you can see, the first wave has more complete waves compared to the second wave. It means the first wave has higher frequency compared to the second waves. We can also say that the higher the frequency, the higher the energy, and the lower the frequency, the lower the energy the wave carries. In the electromagnetic spectrum, electromagnetic waves are arranged by increasing frequency. It means radio waves has the smallest amount of frequency, and gamma rays has the highest amount of frequency. These frequency are measured by hertz. Now, we can also say that electromagnetic spectrum arrange the electromagnetic waves based on their energy. Radio waves having the smallest amount of energy, and gamma rays having the highest amount of energy. Now, another question. Can we see electromagnetic waves? The answer is only one. That's the visible light. Visible light has a frequency that the human eye can perceive or can see. It means in electromagnetic waves with frequency higher or lower than the visible light are invisible to the human eye. Next is the wavelength. Wavelength is the distance between two in-phase points of the wave. It means it's the distance between two highest point or two lowest point of a wave. We can also see that the wave with a shorter wavelength have higher frequency, and the wave with a longer wavelength has lower frequency. Now, electromagnetic spectrum arrange electromagnetic waves based by decreasing wavelength. So we can say radio waves has the longest wavelength and gamma rays have the shortest wavelength. In terms of speed, all electromagnetic waves travel in the speed of light, or t times 10 raised to 8 meters per second. Fun fact, there's no thing in the observable universe faster than the speed of light. So electromagnetic waves are the fastest thing in the universe. Now, to generalize, electromagnetic waves have both electric and magnetic properties. They don't need medium to propagate, and all electromagnetic waves travel in the speed of light. As the frequency of the electromagnetic wave increases, the energy also increases. And as the frequency of the electromagnetic wave increases, the wavelength decreases. And all electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. And that's all for today. I hope you learned something to our lesson, and I hope you keep on watching our video lesson so that you can learn more. Again, thank you for listening and have a great day. Thank you.